Start of the stream. He's coughing. Alright, so welcome back to, building the CPU basically. If you're watching the YouTube VOD, feel free to like, although obviously it's entirely up to you. But, the algorithm does prioritize that kind of thing, so yeah, it would be appreciated. But, yes. Excuse my rampant self-promotion. Right, so I'm working on the control circuit. I am working on the control circuit for this crap here. This basically is the address, the instruction, well, this is basically the address reading and writing control system. So essentially this is the landing stage for the CPU. So instructions will nebulously land here. And then this will send address codes back to the memory over there. Excuse me. And also this will iterate through instructions. Now each instruction will come in the form of an operator code or a machine code or a machine instruction or whatever, and an associated address. So this here is the associated address, right? Because this line here, this is the return CPU line, or the return line from memory, and this is the I call them CPU wood and anti-CPU wood because I find the turn of phrase funny, but it's the return line in the I say that I've completely forgotten what the correct name for the line that goes that way is. But yes, this is the one that returns data from memory, and it will start, obviously, so essentially every second, so it will start by reading an instruction, right? The instruction, excuse me, that was a bit gross. The instruction will contain the operator code here, and then it will also contain an address that will be the address of whatever data it is that will need to be applied. We'll have the operator code applied to it, I guess. So then once it's done that, it will send that address back around here, and then the next data that comes down this return line will be the data that is associated with this address. So it's, as a general rule, what it will do is it will alternate between instruction and memory address fetch request or read or write request. Right, so it'll be instruction request, then memory read or write request, then instruction request, then memory read or write request. And that's generally how the operation will work with this computer. Memory. So yes, that's basically it. But what I need to do is I need to control the timing on this so that it doesn't overwrite this prematurely. And then I also need to add a switch over here. Well, no, it's this switch here I need to control. So I need to do this switch. So you think about it, if because these signals will arrive slightly out of sync, it essentially could create a problem if they turn on asymmetrically, and then they also overwrite this, because if some signals are still arriving and then this is changed, then it could start reading from another address whilst it's another random address essentially whilst it's supposed to be reading from the initial one. Now I think actually with the way the timing works, I think that the design is tight enough, as in the signals will arrive in sync enough for it probably not to be an issue. But at least for now, I'm going to be doing it carefully to make sure that it's But also, right, there's a second issue of it when the obviously when the second instruction, that is the memory addressing the memory read or write instruction, if it's a read, at least if it's a read instruction, when it arrives here, you don't want it to be interpreted as an address, basically, because that will then mess up this. Because obviously it will take some time for the signal to be, obviously the signal will need to be on for a certain amount of time, and then that will be interrupted if the memory address is recycled whilst it's still functioning. So this switch here at least is essential. Now, when I built this like 3 days ago, I had a very clear idea of what I wanted to do with it. Unfortunately, right now it's all sort of left my head. Right now I'm looking at this and I can't even remember why I put this switch in here, but there was a very good reason for it. I mean, is it actually just two switches that do exactly the same thing, and therefore one of them is pointless? Well, no, there is an edge case, right? There will be an edge case where an instruction is not followed by a read or write request, and in that case, this does need to be shut offable. Independently of this, I believe. This is actually a disaster. I've completely forgotten what I was doing. What the devil was I up to? It's also possible, right, that it's something completely stupid here, and this is completely pointless. But I really don't think it is. I think I put this here for a very good reason. Because again, what this is just a switch that turns this on or off, right? But so when would you want that off when this isn't off? Oh, hang on. Yes, I'm completely wrong. This is not a switch. This is a repeater. This is essentially a binary storage tower like this. So this will basically, this allows you to fire the memory address for a certain amount of time, right? This here just allows you to turn the memory addresses off, whereas this here allows you to have it on for a specific amount of time, basically. So that's an important difference, because again, this is basically one bit of storage here, and then it gets switched off by that. So if I do that, that stays on. So this is actually more like one of these stacks over here than it is those switches over there. So essentially you want this to be open on the first cycle. So all needs to be open. This needs to be closed. Right. So all these signals can come here simultaneously, and then they don't go around there and interrupt that. But then as soon as you close this off, you need to open that up so you can read the next, you can go do the next, do the non-instruction memory read or write. So you want, well, there's going to be a signal down here basically. Now, how time sensitive is this? I'm going to say reasonably. So the reason I've used InstaWire here is because I want this switch to turn on essentially simultaneously across the whole width. It's not because I actually want low latency in this particular control system. It's just that I want it to be simultaneous across the top there. Now, to be fair, what I should do to be space saving is route it over there, but what I need is a so imagine timing circuit here somewhere, comes in here, then this goes into a NOT gate. Hang on. So, yes, that's right. So actually, it needs to be the other way around. Because this will. Am I eating crayons? I might be eating crayons. Doing that will switch this all off, which is not what you want. So essentially, when this is in an idling state, you want that switched off. Now when this turns on, you want. Yes, I'm eating crayons. It needs to be It needs to be here, I think. And really want insta wires for this. I shall do something unprecedented. Can I have a new type of insta wire? What am I looking for? Sticky piston, that's the one. Now, all of my insta wires have been made out of wool, if you can believe it. This will be the first one not to be. Of course, it needs one down here as well. Nope, that's not close enough. I know what I can do to fix this. I think like this will work. Sorry, my brain is wandering right now. That's good. That works. That's clever. Well, it's not clever, but it works. Excuse me, my brain rot. Right, so sorry, my brain. Just wondering there. Basically, when this is switched on, that's switched off. So essentially, when it's waiting for new memory addresses to be received, it overwrites these to 0, and then when it's doing a read or write, it opens that and sends it round. Now, the real secret source here is going to be the timing circuit, which is going to be here. I think it does have to be a clock rather than like a switch system. Now I hate making clocks in here because, right, at some point I'm gonna try and modify the game and get these repeaters to work like much faster. And of course, if I do that, my timing circuits are going to be all broken, unless I'm careful about how I do it. Aye, aye, aye. But also, it does need to switch between multiple clocks, so it needs to, or the clock needs to run for like a set amount of time, then reset, and then do the same again. So, I mean, I guess the clock needs to. It's a confusing question. Let me just try some clock design over here. Now, I do have some clock designs elsewhere in this build, but I'm just going to try doing it again so that I can see if I've had any sort of bad design philosophy that needs to be corrected. So what I probably need to do is just plug this into a sensitive switching system like the one over there. Also, it's going to need to be a lot slower than that. Yeah, it's going to be likely to be a fraction of that speed. It's going to be like half that speed or whatever, so like something like this. I mean, redstone people probably know vastly better ways of doing this than this, but I am not a redstone. I don't play Minecraft, so or at least not much. Don't believe your lying eyes. I'm not playing Minecraft. Because essentially, right, I need to take this pulsing signal and turn it into a smooth binary signal. So yeah, up to 16 times the detail. Sorry, up to 4 times slower. It's just sorry. My brain is rotting today. Right, so I need this guy. Oh yeah, that's right, it's the wrong way around. So it is rotate 270. It's the wrong place. So that damaged the... No, it hasn't, but it nearly did. Actually, it did damage it, didn't it? Ugh, that'll do. That'll do. It goes... so this has got... this can store 3 states. In the off state, so this actually stores 4 states because it stores 3 on states and 2 off states. Rather, 1 off state. So right now it's off on every level, right? No, that's on. That is on. Now it should be off on every level. Excuse me. There's the damn input. Oh, it's over here. I should turn the top one on, but it doesn't. Why? Why is this broken? Oh, I know why it's broken. It's because of that. Because it needs a repeater there. Let's check if that's an issue over here. So it's a potential issue in the design, full stop. Just quickly go and correct it over here as well. Sorry, my brain is just... So currently bottom one is on for whatever reason. Bottom one should be on, middle one is off. Top one is off, good. What? Alright, yes, so that's how it's supposed to work. Yes. So it detects when it's turned off, and that's what the middle one's for. Silly of me to forget that. Okay, so so essentially when that turns on, after one cycle the middle one turns on, and then the second cycle will go up into this one here, which will turn this off. And then the third cycle will go back down to the bottom. I still want this off. Or do you? Right, so excuse me. Sorry. Sorry. Right. So second cycle. Second cycle will go. Right. So first time this signal gets activated, that turns the lower deck on. Do you want that then to? Oh my word, this is complicated. So as the clock pulses, that turns the lower deck on, then as the clock pulses off, that turns the middle deck on. Now, given that when you want the clock to pulse, rather when you want the clock to pulse off, you want that to. So essentially you want the first time the clock pulses, you want that to turn this switch on. Or rather you want to turn that switch off, and then that switch. So you want to turn that switch on, then that switch off over there. Now the second, so you can either do that by connecting it to the bottom one here, or no, if you connect to the bottom one, it doesn't work. So you want it to be connected to the middle one. Now the second time the clock pulses, you want it to do nothing, right? Now, do you want it to go back to the bottom? You might want it to go back to the bottom. So the second time the clock pulses should correspond with the data from memory arriving at the CPU, assuming the time is correct. Now, when that happens, you want, or I want this to be shut off here, and I want this to be shut off here. Rather, really, I probably want to open this, don't I? I want to open this in preparation for the next instruction, but I want to shut that. So I want it to cycle again on the next pulse. So that would mean that the timing would be correct, because it would just go to the top layer and then it would go back down to the bottom layer. And then that would be it ready for the next iterative instruction. Now, so to do the instruction cycling, this needs to be tied into that as well, because this needs to read from there out to memory, from here basically. This is what triggers the process to work, and this is the iterator. So this will iterate through instructions, as I explained in the previous stream. But, excuse me, the brain. Right. Oh god. Sorry, I'm very distracted today. Very. Just not about anything reasonable either, but so basically you want this signal to extend out there, up to there, and basically you want get rid of all of this. Don't need any of that. Just need, because I am not going to be adding, because I'm not using relative go-to instructions, right, I don't need to add more than one bit at a time. So what I can do is I can just have the bottom bit here always on. Well, not necessarily always on, but when it's so this here switches switches that on or off, right? And what I need to do then is tie. Don't even need this. That's a switch that tie a NOT gate into this. Right, so that when the when this says to do the calculation, so this line here being in the off position allows these gates to open, which then allows the second number to go into the binary adder, which is when the calculation is performed, basically. And that now I need to make sure that that is coincident with basically the bottom bit being set to 1, because it's an iterator, so it's adding 1 every time. And to do that, all I can do is I can just put a NOT gate on that signal, basically. Dead simple. Now, as for the timing on this, so it needs to receive read signals and write signals. To trigger, so sending a read signal will trigger it to output to memory, to read a memory address, basically. So the first thing it needs to do is receive a read signal, right? So it will receive a read signal that will essentially trigger output from this here, which will send that down the memory bus that will read from the instruction set, or not the instruction set, but the program. So it receives a read signal that will correspond to this here being open and this here being closed. So that will be when this signal is on. Sorry, my brain. When that signal is on, then it goes so as soon as this signal turns off, like it is now, it will go you will need the because it just passively refills the buffer, right? No, it doesn't. There's some complicated timing here because it's not just the this is going to be So I think the problem perhaps here is that where do you get stuff out of here? The offhand thing is so stupid. Why did they add that to Minecraft? Like, and why? Yeah, well, I guess I could change which key it's bound to. That wouldn't hurt. It wouldn't hurt if I changed it from F, but because it's on F, right, I keep hitting it instead of B. So it's what it is currently the read switch is currently tied to this timer, right? But what I'm going to need to do is so it'll read when the timer is set to naught in the idle state. So when the timer is set to naught in the idle state, that will allow the data to come back around here passively. Then when the timer goes into the first state, oh god, this is complicated. I mean, it's not complicated, but I'm just not I'm just not, yeah, I am not enough. Right, so if it is so this switches that. Hang on, so let me just so currently that's in the maximum position. If I switch this, that should go back down to all circuits off, right? Now in that situation, this switch is on. And then it sends down there, which is not what you want. I'm actually not sure why it's doing that. Oh yes, that's why, but it doesn't matter actually. As long as the read switch is off, rather than the write switch. No, the read switch. Yes, this is the right. This is the write switch, and this is the read. So there's a slight problem with this because there's also an inversion here because like I want to write from this or rather read from it, right? But then I also want to. Never mind, the terms are getting confusing. But either way, right? So right now, this is on because that's tied into that, and that is not gated. Now that doesn't really matter because it will get overwritten. Obviously, it's writing junk data right now. But when I switch this to the next level, nothing should change except that should turn on. Which actually changes. Oh, it changes that because it turns that off. Yes. But it still doesn't matter. And then that that opens that up for writing rather, but it doesn't matter again because it's so essentially in the iterator case that state is redundant is I guess what I'm getting from this. Then doing it to that level. This should open up these doors, which turn on the addition, right? And again, finally switching that on should turn on the read. Should it? I feel it should. Hang on, I need to go and I need to go and examine the original. This is a bit silly. I should know this. It should be easy. Yes, you see, I've not got a NOT gate over here. So what that means is that so switching it into that state allows the calculation to be performed. But didn't the other state also allow that? Yes, so these top, in this current configuration, these top two states are both redundant. So that's the first thing I want to fix. But also, I think there is one extra degree of freedom in this whole system that I may or may not want to get rid of. So again, this system will start sorry, once again my brain is wandering. So in that state it will read from there. But then that's broken because that does not turn that on. So you need to turn that off. That then allows it to read to that state. And then it's just the next state that's redundant. So in reality, again, it's going to be starting in this state. So in this state, it sends a memory address out there, waits for that clock to cycle. When that clock cycles, it goes to the next state. This state. Now, no longer is it reading memory addresses out to there. So this goes on to the next cycle where the thing is waiting for the next instruction, right? And when it receives the next instruction and so when it receives the next instruction, I think you want it all to go back to normal. That's the problem. if it does, the problem is if it doesn't work over here, it means it's not working over here as well, doesn't it? So I need to think about why I think it's working there but not over here. It's the exact same circuit. So so you've got the switch. So hang on a minute. Yes, I've thought about this incorrectly. I forgot that it's receiving pulses. No, that's why it's not receiving pulses. This one isn't receiving pulses, whereas this one is. So this one you need double the number of things because it's detecting switch ons and off, whereas this one is detecting continuously. So it needeth it not. So basically, after it's gone into the second state, it needs to be able to have done it needs to go through the next 3 states quickly so that it can be ready to go into the third state again. So in fact, it probably needs its own clock. Because what it wants to do, it needs to go to. So it starts off reading from this, right? Then obviously it flips off. Well, it waits for that instruction to be processed. Then it is ready to send another instruction. So essentially, the only state that is controlled from the outside is this top state here. Right, the outside needs to tell it. It needs to arrive in that top state in sync with the signal from the outside. Is perhaps the problem here. What that means is that when it gets to the bottom state, right, when these signals are both off, so this situation here, excuse me again, my brain is just rotting. This situation here, it needs a feed line back. Well, what it needs to do is start a little circuit of its, a little timer of its own. That could be, it could be a little problematic with the spacing here. Yes, I can use my other style of timer. Just a little bit more, spatially forgiving. why not make it a MOSFET? Get the joke? Alright, yes. Basically what it needs to do is switch it on briefly, switch it off briefly, and then switch it back on again. So switch it on. That writes to that. It's otherwise completely pointless though, isn't it? Yes, this timing circuit is now completely broken for this purpose, so it needs one. Why is this so difficult for me? Then that sends it to the middle state, which is the state where it does the addition, right? And that also sets it to read to that. So yes, so again we arrive at the position where I can get rid of two of these switches. So essentially what I want is a timed system that the read system, so what I actually want to do is I want to tie this here completely out of this here, right? New idea, guys, new idea. This time it will work for real. Bro, please trust me. But what I want that to do is I want that to trigger, not this, I want that to trigger timing circuit here that will rapidly cycle through this cycle here, that will then leave the next number in here waiting for when this signal turns back on again. That's what I want. But also I want, obviously, so when that read switch, so I also want it to end up in the final state where this is open for receiving. So basically that final state. So if it's in this final state, if it's in this state rather finally, then when this reads from there, that will send it around there, and that will write it to that. And then it will go into the redundant state. In the redundant state, now the problem with the redundant state is not a problem at all. So then that's fine. I need to check the design over here again. This is much harder than it should be, I think. I think I am making this much harder than it needs to be. In that state there, that is turned on, which turns that off. Okay, so that's why that's not connected on this one. So I was trying to figure out over there, I was just trying to figure out why it is that there's two states that allow you to read into this. Or rather, write into it. I keep getting read and write mixed up, for which I apologise. But it's because, again, you're reading from this one and then writing it into that one. So it's like you're reading into this from that, and you're writing into this from that. But yes, so if I were to do that, then that would mean that so currently in bottom state, which means that it's currently accepting new numbers into the registry. In the middle state, which means it is dormant. It is in the top state, which means it is doing the addition. Right, okay, so basically it needs so that then switches off, which puts it in the bottom state. So you need two signals, and you need to start in the bottom state, so it ends back in the bottom state. Really simple, really, really simple. I swear, sure. This time, guys, this time. Now, yes, so in fact, let's get some black wool. In fact, it doesn't even need any of that because it's not going to come. It's not going to get signals from that direction. What it needs instead is this. So this gets pulsed at the end here. So when that turns on, it puts it into the read state. It goes in the square hole. Also, having it go this direction is very stupid. Don't know why I decided to do that. Any day now, I'll figure this out. Although I do have to go and do some work reasonably shortly. What time is it? It is 7 o'clock, so I've still got some time. Okay. It's got this signal will go into. So basically, you want. In fact, you want to rearrange this completely. You don't even need this address operator. Firstly, you need a bypass for this signal, so it needs to come like this. Then you need the timer somewhere over here. So firstly, whilst that's on, you want that just to be straight on. But then you want that to turn off, you want that to essentially when that turns off, you want that to trigger a secondary cycle here that will turn that back on briefly. So what you do is you do one of these, do it over here, this, right, and do that, let's say. I know it's ugly. That will pulse this signal. Right. Okay, that's highly dubious. Why is that still on? It's very morally questionable. So if I cycle, so right, so let's test this. I want it to be in the off state at the bottom. It currently is in. This is the idle state. So I send a write request. So sending a read request to that should send the address down that way, and then it should also send that back round to that way. So doing this should open that up simultaneously with opening that up. So it has done nothing of the sort, and I know why that is. It is because there is no repeater here. And there's no repeater along here. It's a very stupid mistake. I mean, it wasn't a mistake, it was just, I don't know, it's just like, yeah. So that's correct, fundamentally. Now, removing this should cause this to turn off instantly. Then it should cause this to cycle, except it won't because this is on, so it'll stay on. That's the problem. Excuse me. Yeah, you see, it just stays on. And does that affect it at all? Not really. Mercifully, I do know how to fix this. Mercifully. Like this. See, that works, but very ugly circuit. Let's redesign it later. Now I just need to get this into the correct state. They're all off. Don't question it. Okay, so doing this should put it into the output and input for the two. So this one should be output, that one should be input. That's correct. Now, as I switch this off, it should cycle back into that state with that off at the bottom. That is on. That's the problem. Now, it might be that that's too fast. Because for whatever reason that's broken, because that is in the probably need to put more here, just so it's off for longer, because it might be that it's cycling too quickly. Right, in fact it's quite likely. back in the bottom, off. Oops, that was a mistake. That was a mistake, but that should fix it. Now doing this again should basically it should arrive back into the same state after I do this. So that bottom one is off, that middle one is off, and that top one is off. So when it receives so it will receive a signal from over here telling it to output data down the bus to get a memory address. That signal will also trigger this side to read into it, and as soon as that signal switches off, it rapid cycles through the addition process and dumps that into there, so that it's ready for the next time it receives this signal. Quite simple. Took me far too long. Oh. Right. Now, obviously, I need to formalize this circuit here a bit, but I could just tie that in as it is for now. So it's in the default state. In this state, right, this is off and then this is on. Excuse me again. Hang on, what on earth am I doing? So that goes there, that goes correctly on top in redstone. Right, so that goes. Yeah, so in this state, this is on, which is correct. As soon as this turns off here, that's allowing the next one to come through. Hang on. This is in fact not so good. I think I've I'm just not thinking clearly tonight at all. This goes in the square hole. No, that's correct. That's correct. And then as soon as this switches off, that's the cue for this to cycle because that's while the non-iterative memory is being used. So it doesn't need this, and then it goes essentially it bypasses that entirely. So it cycles during that process, and then that's one thing I need to make sure that there's no back propagation here. Put that there, and then get rid of this one, I think. Um, and then, of course, when this recycles, so that actually should work, I think, in theory, if that works. Now, I am not going to test any of this yet, precisely because the memory itself is difficult. Right, there's a whole load of work I need to do over here to make sure I don't break it because of the way insta wires work, they need to be in correctly loaded chunks when they're cycling, and I can't remember if I've got it set up correctly. But also, I need to make sure that all of this is loaded correctly. Now, it should really be loaded correctly because it's in my range, but I need to be careful about it. I mean, what I could do is I could just make a backup and then test it. Test the backup, that is, and if I accidentally break it, I can just, well, I'll reload the back. The thing is, it can be quite subtle as to whether or not you've broken it, so it's like, yes. But I'm not going to do that tonight anyway. So, see if there's anything else I can clean up in the meantime, and then I'm getting out of here because I've got some work to do. But, well, I can clean up this, that's for sure. Hang on. I mean, so this was the one I broke by copy paste. But I don't think I broke it that badly, did I? Oh, I know why. Because there would have been a regular repeater here, wouldn't there? And regular. Seems a bit silly. Right, so go here. Now, if you paste something and it breaks the block underneath the redstone, right? It won't. The redstone will break, but it won't go back when you undo. When you undo the paste, it won't restore the redstone because the redstone was not removed by the paste. The redstone was removed by gravity. Right, so that is fixed. I'm actually surprised, but this doesn't look too bad. This section, it's like fairly neat. So now there are other considerations I need to do as well because I need to add in essentially a control circuit over here, and I'm going to introduce a new type of bus. It's going to be the orange bus. Now this bus will carry status codes from the different CPU operators, right? So yes, the CPU operate. Obviously, each CPU logical unit will have a status associated with it. For example, the binary adder will have two statuses. It will have, well, it'll have it will have a status of being unwritten to, and it will have a status of being No, it will have a status of being in process of adding, and it'll have a status of I've now got an added result that needs to be sent back to memory, right? So essentially, whilst it's either empty or it's doing addition, its status will be 0, but once it's done addition and it's got a number stored in the storage stack, this stack here, it will need to send a status code back to the CPU so that it knows that this time it needs to send a write signal rather than a read signal to the memory address. And now I need, firstly I need to put it way over here, like here even, but I need to put basically 16-bit, well, nominally 16 bits, it'd probably be less than 16 bits, but in fact it'll certainly be less than 16 bits, but like 60, because it's 4-bit operator code, so that's 16 potential operator addresses, right? So that's 16 bits that are needed to convey that data, but obviously some of them won't have to have status codes. So I need an orange status bus, right? It will come somewhere like this because the logic will be over there or whatever. Although it's a complicated question because it's slightly depends on what because right now what I'm thinking I will do is I will somewhat convolutedly well firstly actually I need to sort out this layer as well. This has got to go somewhere, so bring that out, but it's not exactly well positioned, is it? Because it can't go forwards because it's got all that there, and if it comes out this way it's still under here. It's all a bit of a complicated. So I suppose what I really need to do so actually both of these buses will need to go this way and then along here. And if I have the logical, either I put the logical operators on that side or more likely on this side here. So likely the logical operators will be in some kind of line along here. And what potentially I could do is I could split these buses. So firstly, actually, it will make sense if I rotate them through 90 degrees so they're horizontal rather than. Sorry, that's just my headphones. So let's rotate them horizontal into vertical stacks, like I've done over here, basically, and then have them running one on this end and one on that end, perhaps. And then in that schema, I would have to have the status code coming out the bottom somehow. And then it would have to go into another stack over here, is what I'm thinking. But yes, that's soon going to be an orange bus. And honestly, this has been kind of a disaster, so I'm going to end stream here. But thanks for watching.